If we look back at our initial web page test report, it records that images accounted for only 33% of requests, yet a huge 87% of downloaded bytes. Looking at the website's images, you can see why. Lots of weighty images which the browser has to spend time downloading, impacting performance. This image in particular sticks out, as it's a photograph saved as a PNG. This isn't very efficient, as PNGs are typically more suited to icons, illustrations, and other similar image types. Let's change this to a more appropriate format for a photograph, JPEG. You can do this yourself in apps like Photoshop or via online converters, but for convenience, you can also just download it from this video's attachments. There's quite a difference between these two formats in file size. In the index template, be sure to change the source attribute for the image from PNG to JPEG, and you can delete the old PNG now. Moving on, just because an image is in the correct format, it doesn't mean it's optimized for web usage. Take the carousel slide on the homepage for example. It's 746 kilobytes. If we look at the homepage in DevTools, we can see that the image's width is nearly 2000 pixels wide, yet when used on the website, the image is never displayed larger than just over half of that. We can reduce the file size of the website, and by extension, reduce load times, by trimming down the dimensions of images to make them a more appropriate fit for how they're used. This way, we aren't spending precious load time downloading images which are much bigger than they need to be. What is an appropriate image size? That depends on the device. When viewing a website on desktop, a banner image may be perfect, but that same image when the website is viewed on a smaller mobile device, not as efficient. Therefore, we'll create two size variants for each JPEG, one for desktop and one for mobile. Let's start with the homepage carousel slides. For desktop, we should size images based on their eventual size on the page. In this case, that's 1110 pixels wide, the size of the image's container. We'll override the existing slide here. For mobile, the image is 375 pixels wide, which sits roughly in between the mobile and tablet viewport sizes, so the image shouldn't have to scale too much in either direction. Here, we'll create a new image with the same file name plus a suffix on the end. As for the rest of the website's images, you have better things to do than watch me resize each image one by one. So instead, download both desktop and mobile variants from this video's attachment list. Let's implement our revised images into the code. The website needs to use the most appropriate image size based on the width of the browser's viewport. There's a number of ways to do this, but I prefer to use the picture element, as here it will allow for more granular control on when we can switch an image to its smaller mobile variant, and vice versa. In here, we place the original image element, and then for each additional image variant, a source element. One in this case for the mobile variant. The picture element will display the smaller mobile variant instead of the original desktop variant for as long as its media query equates to true, which in this instance would be when the browser window is smaller than 768 pixels wide, which for most mobile devices is a given. We can see this in action if we load the website in mobile view. Notice how the mobile variant has been downloaded. Now if we scale up the viewport, once we cross that media query threshold, the browser automatically downloads and displays the larger desktop variant. Perfect. Now let's sort the rest of the images. In this instance, we need multiple source elements, because as the viewport scales up, the image goes from small to big to small again. This way, we make sure the most appropriate image is always downloaded. For this blog post banner, we have an opportunity to optimize even further. If we look at how it's used on desktop, then scale it down to mobile, we can see there's a lot of pixels which are out of view either side of the subject. This means on mobile we're downloading the full banner image despite most of it being hidden. For the mobile variant, as well as shrinking it down, let's better frame it, like this, so what we see on screen is exactly what's downloaded, and not a pixel more. You can grab this mobile image from the video's attachments too. Now, we just need to update the banner's CSS, like so, to make the swap happen at the right time. Then, if we go back to the website in mobile view, it's using the smaller, better framed image. Here is the comparison, and it's looking good. By resizing our website's images, it seems every metric has improved in some way. We have a boost to first render metrics, though I'm thinking that's just incidental, and blocking resources just happened to load a little faster in this run. What isn't incidental though, are the improvements to speed index and largest contentful paint. 36% and 74% faster respectively. This is because this first slide is now loading much faster, meaning the viewport content, which these metrics measure, is also completing much faster. This is very good for the website's perceived performance. There's also been a good drop with time to interactive, which given the improvement to render metrics is to be expected. Bytes downloaded and fully loaded have also dropped significantly, which is also to be expected with far fewer image bytes to download. How fewer? Whilst images still roughly account for the same amount of requests, now they only are responsible for 20% of downloaded bytes. Before that same figure was 87%. Brilliant! Google Lighthouse seems to agree as well. Our performance score has risen by 14 points.